So, like I said, this whole week we are really focusing on reviewing chapter 3. We are going to be focusing on reviewing all those key features, parts, and terms that we have previously looked at. So, we are going to be working on implicit definition of the derivative, tangent line, sine, cosine, secant, cosecant, all our trig derivatives, and really focusing on making sure we have a good understanding of that. So out on our Fusion Flex website, I have posted kind of like what I call our mid-chapter review. So the mid-chapter review, like I said, it's out on Fusion. Our test will be next week, and what I think I'm going to do is make the test Tuesday, Wednesday, Thursday. So the idea behind it would be that a majority of the test questions you take are free response. They'll be on Tuesday or Thursday, depending on what day you're in person. And then our Wednesday will be multiple choice AP style questions. So that's really pushing us all the way to next week. And again, the reason I'm making and prolonging sort of this test so much is because I really need to make sure we have a good understanding of this. So each day this week, we're going to kind of focus and review these key ideas. And we're really going to hit more on motion because I feel like we didn't hit a lot of motion. So we might do, even some new motion problems this week. And then really that only leaves 3 little lessons left to chapter 3. And then we're going to move on to chapter 4. So even though I'm calling it a mid-chapter test, it's really like the chapter 3 test because the next part of chapter 3 is not unrelated, but just different. So we're going to going back to the definition of the derivative. We're looking at continuity and differentiability. We're going to hit IVT, motion problems, our basic rules, our trig derivatives, and then adding to that is implicit. So in order to make sure we are all on the same page, we're going to use that break packet as well as kind of some other things today. So, all right. All right, on derivatives, and that's been the main part of chapter 3. So now that we are finishing up that type of concept, I just want to go back through and look at all of those key things. You can see a lot of that has to do with particle motion. A lot of what you're doing in physics is going to really start to come into play in calculus now. And hopefully it's all starting to become more clear, because that is really the key idea of chapter 3. So I had you guys take out your winter break packets. So what we're going to do for today, the way I'm going to give you guys your points and really make sure you understand everything, is have you take those packets. I've turned it into multiple choice quizzes. You're going to work freely through it. So I'm going to give you about 20 minutes, maybe like 15, to basically go through the problems. The problems should be in the same order on the quizzes that they were on your packet. If they're not, I apologize. I thought I made the settings that they were, but you know, every once in a while things like that happen. So we're going to hang out on here. I'm going to let you guys go out on the quizzes. I can follow along. I'm going to watch the quizzes. And then the reason I'm having you answer on the quizzes is so that I can see what questions we really need to work on and review. It will give me a better idea of what you know and what you understand. So I will put that link up now so that you have the code, and I'll also send it on the Teams channel and on the chat channel in here in case you want to be able to click it. So let's go through and we're going to look at sorting via accuracy. So we got, like I said, a majority of the questions right. If we pick up with question 11, this one was find the derivative of f of x equals x to the fourth sine x. This is a product rule. So it was the first times the root of the second plus the second times the root of the first. So in order to do that, you had x to the fourth times cosine x plus sine x times 4x cubed. So that was this answer choice right here. And again, you can see the only difference between the correct and the incorrect was we picked a negative. Okay, going back up. I was hoping it would keep it in the order that it was, but we need 15 now. So it says, what is the speed? So again, I said we're going to probably focus a lot on PVA problems. So it says, what is the speed of the position of the function at 2? So I'm going to think our biggest mistake was that we didn't take the absolute value. And that's why we got the negative 18. Speed is the absolute value of velocity. So in order to get the correct answer for this question, you had to take the absolute value of your answer, which was positive 18. 26, it says if A comma B is a local min, then what is true about the second derivative? So if you think about the first derivative, if it's a minimum, then the first derivative is 0. If it's a min, then my graph is going from decreasing back to increasing on the original, which means that it is going to be positive on the second derivative. What will be true at an inflection point? So an inflection point is the derivative at that function at its second derivative. So it is 0 because an inflection point is a max or min of the first derivative. Therefore, it is 0 on the second derivative. Name the discontinuity at x equals 2. So if you're looking at x equals 2, there is no discontinuity. What's happening at x equals 2 is we have a sharp corner. Therefore, it's not differentiable. However, it is continuous because you can trace from the red line to the blue line without lifting up a pen tip. So remember, continuity implies differentiability, but differentiability does not imply continuity. What does S prime of t represent? Well, S of t represents position, so the derivative of position is velocity. And down to the final two, or most commonly missed. Find the derivative of 2x squared minus xy plus y squared. So I am going to work this problem out for you. And then before I work that one out, let's look at the next missed question as well. The checkbox question. Select all statements that are true. So we have a function. And on that function, we have discontinuities. We have removable points. We have jump. We have a constant. We have a circular curve. So the first statement says the limit as x approaches -1. So that's as we're looking over here from the positive side. So you're coming from the right is equal to 1. Easy enough. Solid point coming from the right. Got it. The second statement, the limit as x approaches 0 of f of x exists. So here is 0. The limit from the left equals the limit from the right. Therefore, the limit exists. It's not continuous, but the limit exists. Number 3, the limit as x approaches 1, so here we're approaching 1, equals 0. This is false because the limit as x approaches 1 from the left is 1. The limit as x approaches 1 from the right is 0. Therefore, the left-hand limit does not equal the right-hand limit. Therefore, the limit does not exist. And limit as x approaches 0 of f of x equals 1. So here's 0. Limit from the left, limit from the right. The limit as x approaches 0 of f of x is 0. Limit as x approaches 0 of f of x is 0, not 1. And then the last one, the limit as x approaches -1 from the left. So here's -1 from the left. There's nothing happening from the left, therefore the limit does not exist. Okay, so now we're going to talk about that 2x squared minus xy plus y squared. So we have 2x squared minus xy plus y squared equals 0. This is going to be an implicit differentiation problem. So you start with taking the derivative of 2x squared. So 2 times 2 is 4x dx, which is 1, minus, and now you have a choice. You either keep the negative outside or you keep it with the x. So I'm going to keep my negative on the outside. So then I have the first, which is x, times the derivative of the second, which is dy dx, plus the second, which is y, times derivative of first, which is 1, plus derivative of y squared, which is 2y dy dx, equals 0. Now what needs to happen is that negative is going to distribute to both parts inside. So you have 4x minus x dy dx minus y plus 2y dy dx equals 0. And then what I'm going to do is get the dy dx's on the left and the other stuff on the right. So you have negative x plus 2y dy dx equals negative 4x plus y. And then you just divide by what's being multiplied by dy dx. So you have y minus 4x over negative x plus 2y. And again, the order of the terms doesn't matter. I could have left it negative 4x plus y. I could have made it 2y minus x. So if we go back to our multiple choice options, what we'll notice is that it was the 4x minus y over 2x plus y. So again, manipulating my terms to match theirs, or my quizzes rather. Bring out a negative 1. That changes your bottom to positive x minus 2y. Okay, so I don't know if you can still see my screen. There we go. So again, you can, like I said, you can manipulate this in a bunch of ways. So we have this variation. If you bring out, which is what I was doing here, you can bring out a negative 1 on top. And that would give you a positive 4x minus y over 2y minus x. You could distribute that down. So a whole bunch of different ways to move and manipulate. Are there any other questions? And you can send it on the Zoom chat on any of these problems we did.